Good morning, students. Today we are going to start an important chapter in physics, that is motion. Motion is an integral part of the universe, we know. In our everyday life, we see many objects, some moving and some may not be moving. We see some objects at rest and some others in motion. And some examples of moving objects are the birds that fly, the vehicles that run, then the fishes that swim, and you know that the blood that is moving, flowing through the veins and arteries, and moving air. These all are examples of motion or moving objects. You know, in this only, some movements we can see, or we can infer some movements through direct evidences, and some can be inferred only through indirect evidences. In the examples that I mentioned, the movement of air, we can infer it only through indirect evidences like that of the movement of the leaves or the branches of the trees, or otherwise the dust particles that move, that indicate it's because of the movement of air. The other thing, the flowing of the blood through arteries and also the blood vessels. And another example, motion of the earth. You know that earth is moving, planets are moving, the galaxy, it is moving. So earth is moving. How can you infer it? Because it's only because of the motion of the earth sunrise and sunset happens, and also the change of seasons, all because of the motion of earth. And when the object changes its position with time, we can say that the object is moving. So what is it? When can you say that an object is moving? When the object changes its position with time. A simple example is in here. I am standing near the board. See, very close to the board. So now this is my position. Now see, I've changed a little bit. I've moved a little bit forward. That means with respect to this board, whiteboard, my position is changed. So we can say that I have moved. So there is motion. So what is motion then? When any object changes its position with respect to some other object. Here the other object is with respect to the whiteboard. I have changed my position. So we can say that I have moved, or I am in motion. Clear to you? So what is it? When any object changes its position with respect to another object, we can say that the object is moving. And here the board, it is called as the reference point. So board can be called as the reference point. With respect to this, with respect to the reference point, the object changes its position. Then how can you define motion then? Motion can be defined as, or otherwise motion means the change in position of an object with respect to some reference point. The earlier example I have given, which was the reference point? The board is the reference point. So, and what is reference point then? The point from which the change in position of an object is observed. It is called the reference point. So, and see here, this is an object that appears to be moving for one person. It appears to be stationary for some other persons. So what I said, an object which appears to be moving for one person, it appears to be stationary for some other person. For example, suppose you are traveling in a bus. Then when you travel in a bus, you must have observed that the roadside trees, they appear to be moving backwards. And for a person who is standing on the roadside, the bus along with the passengers are moving. But the passengers inside the bus, they see what they observe, their fellow passengers to be at rest. And for them, only the trees, the outside things, they are moving. Listen here. Suppose a person A. The person A is traveling in a bus. He is in the bus. And another person, let it be B. He is standing near a bus stand. Let it be near a bus stand. And he is watching the bus which is coming towards the bus stop. And you know, for the person A, he is there in the moving bus. And for him, the trees which are there on the roadside, they appears to be moving backwards. You also must have experienced the same, isn't it? There. But for this person, what is moving? The trees which are outside appears to be moving backwards. But for him, whoever is sitting with him inside the bus, when he looks at him, they remain stationary. For him, the people who are there in the bus, they are not moving. They are in their seats. But for the person B who is standing outside in the bus stop, for him, what about the trees which are there? They are not moving. They are stationary. They are at rest. But for this person B who is outside or on the roadside, for him, the bus is moving. And as the bus is moving, the passengers inside the bus is also moving along with the bus. Clear to you? That is, the viewpoint, it is different. So that's what I told you. The motion that appears to be, an object that appears to be moving for one person, that appears to be stationary for the other person. The case of the trees. For A, the trees appears to be moving, but for B, it is stationary. And for B, the bus and the fellow passengers are moving, but for A, they are stationary. For the fellow passenger is stationary. Is that clear to you? That means what's that? An object is moving or not moving or stationary. It depends upon what? The one who is observing it. And the object, one object that appears to be moving for one person appears to be stationary for another person. There are different types of motion. Some objects, they move along a straight line. That is the straight line motion, moving along a straight line. Some objects, they move in circular path. Some objects move in circular path. You must have observed the motion of the fan. And so some objects, they vibrate, like that a tuning fork when it is vibrated. And some objects, they make to and fro motion or sidewise motion also. So what is it? Rotational motion, circular motion, vibrating motion, or some objects vibrate, and straight line motion. So there are different types of motion. So here in this chapter, we are going to study motion along a straight line and also circular motion, that is uniform circular motion. Two types of motion we will study. First we can study motion along a straight line. Motion along a straight line is the simplest type of motion. Motion along a straight line is the simplest type of motion. So, now we shall describe this with the help of an example. See that. Consider the motion of an object along a straight line. The object starts its journey from the point O, and that is taken as the reference point. So O is the reference point. And A, B and C are the position of the object at different instants. So which are they? At different instance, we can consider the position of the objects as A, now C, B, and let it be C. So 3 points I marked which indicates the position of the objects at different instance or at different time intervals then. And at first the object moves to A through this C. At first the object starts its journey from O. So let me mark it as here 5, 10, 15, 20, 25, 35, 40, 45, 50, 55 and this point is 60. So A. See that. The object starts its journey from the point A, O I told you, and it moves to A through the points C and B. Now see that first it starts from O and it moves towards A. Now how much kilometers the object has travelled then when it reaches to A? That is 60 kilometers. Now see, then it moves back and it reaches the point B. So first it travelled from O to A. How much it travelled? That is 60 kilometers. Then from there it moves back and reaches the point B. How much is travelled? 60 minus 30, that is 30 kilometers. Clear to you? So total path travelled by the object when it reaches the point B after going to A, it is 90 kilometers. Isn't it? Now again the object moves and finally it reaches the point C. When it reaches the point C after going A, how much? 60 minus 20, that is 40. That is total 60 kilometer plus 40 kilometer, that's equal to 100 kilometer at the point C. Here when it reaches, that how? Then O to A, then to B. Here O to A, then to C. This is the total. Now see, when the object reaches the point B, what's the final position of the object? That is, the object has reached the point B. That is, the object is at a distance of how much kilometer from the reference point? 30 kilometer. So that's the final position of the object when it reaches the point B. Clear to you? And but the total distance travelled when it comes back to B, it is 90 kilometer. And this 90 kilometer is the total length of the path covered by the object. But what is the shortest distance measured from the initial position O to the position B? Shortest distance measured, that is only 30 kilometer. That's the shortest. So, and this is called by the name displacement. What it is called? Displacement. And displacement we can find out by taking the difference between the initial and the final position. And distance means how much the length is covered, the total path covered, that should be considered as the distance. And for measuring the distance, we need only the numerical value or only the magnitude, how much, that is 90 kilometer or 100 kilometer, only the numerical value. But to measure displacement, we need both the magnitude and also the direction. That's one of the difference between the distance and displacement. Distance can be explained only by giving the magnitude or the numerical value. But displacement, to explain it completely, we need both magnitude and direction. Here, what is the displacement of the object when it reaches the point B? It is 30 kilometers towards B. Which direction? How much it is displaced and to what direction it is displaced. That also you have to mention. So see, here in one of the quantity, this is the distance. One of the quantity we can explain it only by the magnitude, and such quantities are called by the name scalar quantities. They are called scalar quantity. But there are certain quantities that can be explained both with magnitude along with direction. We need both magnitude and direction to explain that quantity. They are called by the name vector quantities. What they are called? Vector quantity. So displacement is an example of a vector quantity, whereas distance is an example of scalar quantity. And other examples of scalar quantity is temperature, then mass. Examples of scalar quantity, and same way vector quantity in 8th standard you studied about force. Force is an example of a vector quantity. So the two physical quantities, the distance and the displacement, they are used to describe the overall motion of an object and to locate its final position with reference to its initial position at a given time. Now we can see what is meant by uniform motion and non-uniform motion. That is uniform motion and non-uniform motion. Uniform. For example, listen. Suppose a vehicle covers 50 kilometers in 1 hour. In 1 hour, in the first 1 hour, the vehicle covers a distance of 50 kilometers. The next 1 hour also, it covers 50 kilometers. That's the next 1 hour. The third hour also, it covers 50 kilometers. That means the distance covered by the vehicle is the same in equal interval of time. The time interval remains the same. Every hour, every 1 hour, the distance covered is 50 kilometers. Then such type of motion is called uniform motion. Then what is it more uniform motion? Equal distance in equal interval of time. In equal interval of time. That is called uniform motion. Clear to you? But then what is non-uniform motion? The time interval remains the same, equal interval of time, if the object covers unequal distance. That is unequal distance in equal interval of time. Equal interval of time. It is called non-uniform motion. Clear to you? If an object covers equal distance in equal intervals of time, the motion is called uniform motion. And if the object covers unequal distance in equal intervals of time, it is called non-uniform motion. Examples for what? You know that through a crowded street, it will be difficult to drive, isn't it? That we cannot maintain the same distance in same equal interval of time. We cannot cover equal distance in equal interval of time. Then that's an example of non-uniform motion. And other case also, while driving through a road, if somebody crosses the road, we have to reduce the speed. Then also what is the speed cannot be, so the distance will not be the same in equal intervals of time. And that motion, it is called non-uniform motion. That's the difference between uniform motion and non-uniform motion. We have learnt two important physical quantities used to describe motion, that is distance and displacement. Now we are going to see three more physical quantities that is used to describe motion, that is speed, then velocity, acceleration. Speed, velocity and acceleration, they are the other physical quantities that help us to describe motion. We can see it one by one. First, we will study about speed. Speed, that is measuring rate of motion. First is speed. That is measuring rate of motion. You know that different objects, they may take different amounts of time to cover a given distance. And you know that some objects, they move fast and some objects, they move slow. But there are certain objects, they can move at the same rate also. And one of the ways of measuring the rate of motion of an object is to find out the distance traveled by the object in unit time. That means if you find out how much distance is traveled by each object in the given time, we can compare the motion of the objects. And this quantity which is used to compare the motion of the objects, that is called as speed. Then how can you define speed, or how can you find out speed? Speed can be calculated by dividing the distance traveled by the object with the time taken to cover that distance. The time taken. Understood that? So, what is speed then? Speed can be defined as the distance traveled by the object in the given time period. So, to calculate speed, speed is equal to distance traveled upon time taken to cover that distance. And what is the unit of speed? How will you write in which unit? So, distance if it is measured in meter and time if it is in second, then the unit of speed, it is meter per second or meter second raised to minus 1, or it can be centimeter per second or centimeter second raised to minus 1, or higher units like that of kilometer per hour also can be used to denote the speed. Is that clear? Now, to specify the speed, we require only its magnitude. So, speed can be described only with the numerical value, that is with the magnitude alone. With the magnitude alone, we can describe the speed. And you know, such quantities are called scalar quantities. So, speed is an example of a scalar quantity as it needs only magnitude. Then, the speed of an object, it need not be constant. And in most of the cases, the object will be in non-uniform motion. You know that non-uniform motion means the object will not cover equal distance in equal interval of time. The distance covered will be unequal in equal interval of time. So, objects in most of the cases, they may be in non-uniform motion. And therefore, we describe the rate of motion of such objects in terms of their average speed. So, as most of the time the objects are in non-uniform motion, so the speed should be, we have to calculate the average speed of the objects then. And average speed of an object, it is obtained by dividing the total distance travelled with the total time taken. So, how will you find out average speed? So, average speed is equal to total distance travelled upon total time taken. So, it has to be the total distance travelled upon total time taken. That's the average speed of the object. And suppose, with symbol how it can be denoted. Suppose the distance travelled is S. The time taken be T. then the speed v can be written as v is equal to s upon t. Is that clear? V is equal to s upon t. So what is speed? What's the formula? How to calculate the speed? What's the unit of speed? Speed is a scalar quantity, as only magnitude alone can describe the speed. And most of the cases, as there is non-uniform motion, the average speed has to be calculated. Average speed is equal to total distance traveled by the object divided by total time taken. The next physical quantity, that is velocity. It is velocity. That is speed with direction. We can say it as speed with direction. Now see, the rate of motion of any object, it can be more comprehensive if you specify that its direction along with the speed. So if you specify the direction of motion along with the speed of the object, the rate of motion of the object, it can be more comprehensive. And the quantity that specifies these both aspects, it is called as velocity. And what is it? The quantity that specifies the both the aspect. What is both the aspect? Speed and direction. And that is called as velocity. Now, velocity is the speed of an object moving in a definite direction. So what it is there? The speed of an object. Well, what is velocity? The speed of an object which is moving in a particular direction. While explaining speed, I told you speed need only magnitude. But velocity, we need both magnitude and also direction. So velocity is an example of which quantity? It's an example of vector quantity, as it needs both magnitude and direction. Then the velocity of an object, it can be uniform or it can be variable. Or velocity of an object, it can be uniform velocity, or the object may possess variable velocity or non-uniform velocity. And the velocity of an object, it can be changed by, how can you change the velocity of an object? It can be changed by changing the speed of an object. By changing speed, then it can be changed by changing the direction of motion of an object. Or the velocity can be changed by changing both speed and direction. So we can change the velocity of an object by three ways. First one, by changing the speed of an object. Second, by changing direction of motion, or by changing both speed and direction. When an object is moving along a straight line with variable speed, we can express the magnitude of its rate of motion in terms of average velocity. So what is it? The object is moving along a straight line. That means the direction remains the same. Then, but the speed is different. So definitely the velocity will be different then. So we can express the magnitude in terms of the average velocity. So how we calculated average speed? Same way here also, average velocity then. And the average velocity of the object changing at uniform rate, then average velocity is given by the arithmetic mean of the initial velocity and the final velocity, the given period of time. So, in which case, if the velocity of the object, if it is changing in uniform rate, if the velocity is changing uniformly, then we can calculate the average velocity by taking the arithmetic mean of the initial velocity and final velocity. So, in uniform rate, if the change is in uniform rate, the change of the velocity is uniformly, then we can find out average velocity. Average velocity can be calculated by taking the arithmetic mean. In maths you must have studied how to find out the arithmetic mean. Initial velocity plus final velocity divided by 2. That is how we can calculate the average velocity if the object is moving in uniform rate then. And mathematically, how can you express this? If the initial velocity of an object, if it is u, and final velocity if it is v, then we can write it mathematically as v average is equal to u plus v upon 2. This is how we can calculate the average velocity. Is that clear to you? Now, what about the unit? Velocity. What is velocity? Speed with direction upon time. Otherwise, we can say it is a displacement upon time. So, and as it is a speed, we give the unit to the magnitude. So, as it is the speed with direction, the unit of speed and velocity remains the same. That is meter per second or centimeter per second, or the higher units like that of kilometer per hour. That's the unit of velocity. Now, the third physical quantity that we are going to see, that is acceleration. Next physical quantity, acceleration. Or we can say rate of change of velocity. Rate of change of velocity. Rate of change of velocity. Now, during uniform motion, you know that uniform motion of an object along a straight line, the velocity remains the same with time, or it's not changing. In that case, the change of velocity of an object at any time interval, it remains zero. That means when an object is in uniform motion along a straight line, the velocity, the change in velocity is zero. There is no change of velocity. And in that case, we can say that the rate of change of velocity is zero, or otherwise we say that the acceleration is zero then. But in non-uniform motion, you know that the velocity, it changes with time. So, non-uniform motion, velocity changes with time. And it has different values at different points of its path and also at different time intervals. And in this case, the change in velocity at any time interval, it is not zero. And to explain this quantity, we use a physical quantity that is called by the name acceleration, which is a measure of the change in velocity of an object per unit time. So what is acceleration then? Acceleration is equal to change in velocity of an object in unit time. Otherwise, how can you define acceleration? Acceleration can be defined as rate of change of velocity, or acceleration is equal to change in velocity upon time. As it is a rate of change of velocity, we know that velocity is a vector quantity. So acceleration is also a vector quantity. We need both magnitude and direction. And what about the unit of acceleration? It is meter per second square or centimeter per second square, because here itself we know that velocity meter per second upon second. So meter per second square or centimeter per second square. That's the unit of acceleration then. And if the velocity of an object changes from, for example, initial value u, it changes to the final velocity v for a time t, then we can write acceleration a is equal to v minus u upon t. Change in velocity, that is final velocity minus initial velocity upon time. That is the acceleration. So, this type of motion, it is called as accelerated motion. And what is accelerated motion? If the velocity increases from initial to final, if the velocity increases, then that acceleration is called, that That motion is called accelerated motion. Now, the acceleration is taken to be positive if it is in the direction of velocity, and the acceleration is taken to be negative if it is in a direction opposite to the direction of velocity. So which acceleration? Positive acceleration and negative acceleration. So acceleration can be positive or negative. When it is positive, when the acceleration is in the direction of the velocity, it is positive, and if it is in a direction opposite to the direction of velocity, then it is considered to be negative. Is that clear to you? Next. If an object travels in a straight line and if its velocity increases or decreases by equal amounts in equal interval of time, then that acceleration is said to be uniform. So what is meant by uniform acceleration then? Uniform acceleration. Uniform acceleration. That is, if an object travels in a straight line, the motion of the object should be in a straight line. And what about the velocity? Velocity increases or decreases. It can be increased or decreased in equal amounts, in equal interval of time. Then the acceleration is called uniform. So it is called uniform acceleration. An example of uniform acceleration, any object falling downwards, that is freely falling bodies, is an example of uniform acceleration. And an object can travel with non-uniform acceleration also. When, that is, if the velocity changes at non-uniform rate, so the velocity increases or decreases in non-uniform rate, then the acceleration is called non-uniform acceleration. It is called non-uniform acceleration. For example, a car which is traveling on a road, on a straight road, it increases its speed by unequal amounts in equal interval of time, then we can say that the car is moving with non-uniform acceleration. But it is a car which is moving on a straight road. The speed it increases not by equal amounts, in unequal amounts in equal interval of time. Then we can say that the acceleration of the car is non-uniform acceleration. I hope today's topic is clear to you from the beginning. What we have learned, it is definition of motion, the concept of motion, and what you mean by reference point, uniform motion and non-uniform motion, motion along a straight line, and how to describe it or how to explain it. Then the physical quantities, distance, definition, displacement, differences between distance and displacement, then speed, velocity and acceleration. I hope the topic it is clear to you, and the next class we will discuss about the graphical representation of motion and also equations of motion. Thank you.